Next slide. So what you see on the screen now is a reminder that this advisor webcast is intended for information purposes only. Any features or functionality described for Oracle's products remain at the sole discretion of Oracle. Next slide. So now let's get started with our presentation. Srinivasa, if you're ready, I will turn the webcast over to you and you can begin.
Yes, thank you, Dirk. Hello, everyone. My name is Srinivasa, and I will be delivering the webcast today on troubleshooting issues with TCPS configuration and communication on database. The topics covered in this session are basics of transport layer security configuration, validating TCPS configuration on database, shooting SSL handshake. What are errors that may occur while you use the Oracle database SSL adapter? We will start with the basics of transport layer security configuration. First, let us understand the basic terminologies related to SSL and TLS configurations. What is SSL or TLS? SSL or TLS, it creates an encrypted connection between server and client servers, allowing for private information to be transmitted without the problems of eavesdropping, data tampering, or message forgery. To enable SSL on a website, you need to get an SSL certificate that identifies you and install it on the server. Why do I need SSL? So if you're transmitting sensitive information on a website, such as credentials or personal information, you need to secure it with SSL encryption. It is possible for every piece of data to be seen by others unless it is secured by an SSL certificate. What is an SSL certificate? SSL certificates are small data files that digitally bind a cryptographic key to an organization's details. We had different types of SSL certificates. First is user or server certificate. SSL certificate issued to a specific server host or application is termed as server certificate, or it's also called as user certificate or identity certificate. Intermediate certificate. Intermediate certificates are used as a stand-in for our root certificate. We use intermediate certificates as a proxy because to keep root certificates behind numerous layers of security, ensuring its keys are absolutely inaccessible. Root certificate. Root certificate is a public key certificate that identifies the root certificate authority. Now, what is the certificate authority? Certificate authority is an entity which issues digital certificates to organizations or people after validating them. Certificate authorities have to keep detailed records of what has been issued and the information used to issue it, and are audited regularly to make sure they are following defined procedures. Next is the term wallet. What is a wallet? A wallet is the repository of security certificates and credentials. Oracle database and Oracle HTTP server store certificates in wallets. We can create password protected wallets and also corresponding auto login wallets, which we call it as cwallet.sso. What is a signature algorithm? This is the algorithm used to create a signature. Signature is to verify that it came from the issuer. It is used to sign the certificates. Signature strength is directly related to the key size. The larger the key, the stronger the signature. What is a cipher? In cryptography, a cipher is an algorithm for performing encryption or decryption. A cipher suite is a named combination of authentication, encryption, message authentication code, and key exchange algorithms used to negotiate the security settings for a network connection using the TLS or SSL protocol. SSL handshake. What happens in SSL handshake? The client and server establish which algorithms to be used. The server sends its certificate to the client, and the client verifies that the server certificate was signed by a trusted certificate authority. If client authentication is required, the client sends its own certificate to the server, and the server verifies that the client certificate was signed by a trusted CA. The client and server exchange key information using public key cryptography. Based on this information, each generates a session key and SSL session is established. Now continuing with basics of transport layer security. Transport layer security is an industrial standard protocol for securing network connections. TLS provides authentication, data encryption, and data integrity. It is the foundation of public key infrastructure. For authentication, TLS uses digital certificates that comply with the X509 version 3 standards and a public and private key pair. Oracle database TLS can be used to secure communications between any client and any server. You can configure TLS to provide authentication for the server only, the client only, or both the client and server. Now, let us go through the steps for creating SSL wallet, raising certificate signing request, and importing the certificates to the wallets using ODA-PK utility. ODA-PK is available in the database home. SSL wallet need to be created using the ODA-PK create command. After the wallet is created, need to raise a certificate signing request. That is, we call it a CSR to present our requirement for SSL certificates. Export a CSR created to a file and submit the CSR to certificate authority to get signed SSL certificates in base64 format. Certificate authority will provide a signed user certificate along with the CA, root, and intermediate certificates. First, you need to import the root certificate to the wallet. If any intermediate certificate is provided by certificate authority, it needs to be imported also. Once both the root and intermediate certificates are imported, you need to import a user certificate to the wallet. Now that the wallet is ready, we can review the contents in it using the ODA-PKI display command. Similarly, create a wallet on client and import the DB trusted certificates to the client wallet. After the creation of wallets, SSL or TLS is enabled on the DB with the steps specified in the document. In this session, we are not going to the details of it, as the focus is mainly on troubleshooting the TCPS configuration. Database can be connected over TCP protocol once these documents are followed. Now that the wallets are created and DB is configured for SSL, let us validate and verify the TCPS configuration on database. Check the status of listener. It will list the connection details with protocol as TCPS under listening endpoints, which means listener is configured for TCPS. Now, let us check the entries related to TCPS or the SSL in the database configuration files. Listener.oda will have an address entry with protocol as TCPS. SSL wallet location will be added in listener.oda. Also, there will be parameters SSL client authentication and SSL version. SQLnet.wada file on the database home will also be updated with the SSL wallet location. Now, let us check the configuration files in the client that is connecting to the database. SQLnet.wada on the client will also be updated with the SSL wallet location. Here, the wallet is the wallet created for the client. TNS names.wada on both client and server will have an TNS entry with protocol as TCPS. Once these configurations are all set, we can test the connection to TB to 3CPS connect string. After the connection, we can run the query to verify that the connection is established over TCPS channel. And it will return the output as TCPS, which indicates the current SQL session is through TCPS. We will now validate the SSL wallets on database server and client. The contents in the wallet can be dumped using the display command. The wallet on DB server will contain an entry for the user certificate, which is mandatory. In the same way, we can set the certificates in the wallets on client also. It will contain the root certificate and intermediate certificates, if any, of database under the trusted certificate section. Now, let us go through the steps to troubleshoot connection failures to database caused due to SSL handshake failures. Follow the checklists below when connection to DB fails over SSL connection. We need to verify if listener is accessible through SSL or TCPS port. DB connection can be checked only after the listener is accessible through SSL port. Check the status of listener and ensure it contains a connect descriptor with TCPS. Make a note of host name and port specified in TCPS connect string. Also, check the database service is registered with the listener. If database is not registered, check if the correct listener is used or any issue with the DB registration with the listener team. We can run the OpenSSL command to verify if listener is able to read and load the SSL certificates in the wallet. OpenSSL is an OS level utility and can be installed on Windows OS also. Once we run the OpenSSL command, we can run it pointing to the host name and a port, that is the TCPS port of the listener. If it is reading the certificates properly, it will load the certificate chain, the user certificate, and here the root certificate of the from the DB server CA. If any intermediate certificates are present, they will also be listed in the certificate chain. So this will give us the information on the complete certificate chain used by the database listener. The OpenSSL output also provides the signature algorithm and the protocol being used during the SSL session. As we see here, in the current session, TLSV 1.2 protocol is being used to access the listener port. It also provides a cipher being used during this SSL negotiation. the certificate key strength is also listed in the output. So OpenSSL command will confirm us what are the certificates with which the listener or the database is registered with. If the OpenSSL output report error, then it indicates that the listener is not listening on the TCPS port. Hence, no connection can be established over the SSL and it fails. So need to fix this issue first. As we see here in the output, its report, though it says connected, it's basically the OpenSSL response, but the connection has not happened. So it's returning the handshake failure and no certificates are loaded. So when listener is not listening on TCPS port, we need to fix it by changing the configurations. Check the wallet location specified in listener.wara file. Ensure that this wallet location is valid and it contains the cvalid.sso file in it. If the cvalid.sso is not present and only evalid.p12 file is present, we need to create the auto login wallet again. Check the permissions of the wallet files. The OS user who has started the listener and the database need to have at least read permissions on the wallet files. Dump the contents of the wallet using Aura PKI display command. Verify the wallet contains an user certificate, which is mandatory. Verify it contains the trusted root and intermediate certificates, if any, of the database. If any of these is missing, they need to add the missing certificates or recreate the wallet correctly again. If the required certificates are all present, dump the user certificate that was obtained using Aura PKI command. Check the validity of the certificate and ensure it is not expired. If the certificate has expired, recreate a wallet with new certificates. The certificate display command will also give us the information on the subject of the certificate, that is the user certificate details, and also the issuer, whether it's the intermediate certificate authority or the root certificate authority that has issued this certificate. If the listener is listening on TCPS port and OpenSSL is listing the certificates, then it's sure that the listener is listening to the proper TCPS port. So we need to perform a TNS ping test to listener over TCPS. If the connection is successful, the response we get is okay. It means we are whatever the client that is making a TNS ping connection, it's able to establish a SSL handshake with the listener. In case of failure, the response returned is protocol adapter error. It means though the listener is listening on the TCPS port, any client's connections to the listener or the SSL layer is failing. Need to triage with this checklist when the TNS ping connection fails with TNS protocol adapter error. Check the wallet location specified in the SQLnet.wara on DB or client from which TNS ping is run. Check the wallet location specified in SQLnet.wara on DB or client from which TNS ping is run. Ensure that the location is valid and it can contain the cvalid SSO file in it. Dump the certificates in wallet using Aura PKI display command. check that the trusted certificates of database are listed in it under trusted certificates section. Here we are checking the client wallet from which the TNS ping is established. So it should have the trusted certificates of used by the database. It should contain the root as well as the intermediate certificates, if any, used by the DB server. We can know the certificates used by the TCPS port using the OpenSSL command referred earlier. If any of the certificates are missing, import it to the wallet and try again. Also, check if the parameter SSL client authentication is set to true in listener.wada. What is this SSL client authentication? When the SSL client authentication is set to true, it means it is a two-way SSL connection. The connection from the client will be authenticated by the database, wherein the database, along with the SSL handshake between the client and database, it also wants to ensure that the database is able to trust the client certificates. In that case, check that the trusted certificates of client are imported to the database wallet. It should contain the root as well as intermediate certificates, if any, used by the client. If any of the certificates are missing, it should be imported to the wallet and tried again. The commands to import the certificates were as same as discussed earlier in the session. Also, check the SSL version value set in the SQL.wada of the client. It needs to match the SSL value version set in the listener.wada. If TNS ping is working correctly to listener or TCPS port, then try the connection to the database with TCPS service name. If this connection fails, it will return WADA error with SSL. Now let us see how to triage this failure. At this point, what we have already verified is connection to the listener is working properly. The TNS ping is able to establish the SSL connection to the listener. So this is the second handshake that happens from the client to the database. Check the SQLnet.wada in the database home for the wallet location and ensure the wallets are same as set in the listener.wada. If the wallets are different, check if your requirement is for different set of certificates for database and if those trusted certificates are imported to the client wallet. If it is not the same wallet location, set the same wallet location in listener.wada also for the SQLnet.wada. Check if the parameter SSL client authentication is set to true in SQL.wada of DB home. If yes, dump the wallet used by the database in SQLnet.wada. And check that the trusted certificates of client are imported to it. It should contain root as well as intermediate certificates, if any, used by the client. If any of the certificates are missing, import it to the wallet and try again. Check the SSL version value set in the SQL.wada of the client. It needs to match the SSL version value set in the SQL.wada of the database. If the SSL version is 1.2 on the client and the same should be set on the database server also. If the version is mismatch is there, if the client has SSL version 1.1 and the database has 1.2, then the SSL handshake will not happen because there is no common SSL protocol version. So in the same way, we should ensure that the SSL version in the database home SQLnet.wada, database home listener.wada, and the client SQLnet.wada should all match. Once all these checks are performed, if the troubleshooting To continue, if the error still persists, we need to enable SQLnet tracing to identify and troubleshoot the errors from the SSL layer. The document is specified here to enable the SSL tracing. More debug details on this SSL tracing and the Wireshark usage will be covered in the next webcast that will be on the troubleshooting TCPS SSL through Wireshark. You can enable these traces and you can contact the Oracle support for assistance on what should be the further process for tracing. Now, based on this SSL traces and the errors that were reported, let us see what are the common VODA errors that will occur when we use the Oracle database SSL adapter for connection between the client and the servers. TNS protocol adapter error. This is the same error that was discussed earlier. We need to ensure listener is accessible through SSL port and TNS ping works correctly to the listener. VODA 29024, certificate validation failure. When the certification validation failure, it means the client is not able to trust the database certificates. Check that the client wallet and ensure all the trusted certificates of DB are imported to it. Then we can get the trusted certificates used by the DB using the OpenSSL command. It will list the complete certificate chain of the database or the listener. So we should verify the certificates there and ensure all those root and intermediate certificates are imported to the client wallet. Also, we should ensure that the server certificate of the database, that is the user certificate, it should not be imported as the trusted certificates. In the client wallet, we need only the root and intermediate certificates, if any, used by the database to be present. What are 29143 or 29106? Wallet open failed. For DB versions or client versions less than 12.102, 20.10.20, apply the patch 231.84013 to fix this error. Also, this error is also seen sometimes when the cwallet.sso, that is the auto login wallet, is created with auto login local option. The auto login wallet can be created from the ewallet.p12 either with the option auto login or auto login local. The wallet is created with auto login local, then it is accessible only on the server which it is created and by the user who has created it. So if the wallet is auto login local, and if the same wallet, if you have copied to a different machine to be used, then those wallet will not be accessible and it will return the error. So it's always in that case required to create the wallet as auto login only. What are 28860? Fatal SSL error. This indicates that there is a mismatch between the SSL protocol version or the cipher suits used between the database server and database client. The SSL protocol version that is mentioned in the parameter SSL_version in the configuration files. So if there's a mismatch in the versions, then it will return ORA 28860 error. In the same way, if you are explicitly specified the cipher suits, SSL cipher suits in any of the DB configuration files or the client configuration files, need to ensure the same cipher suit is available and supported on the other party, that is the database also. ORA 28864, SSL connection closed gracefully. This error happens when the certificates have been signed using the MD5 hashing algorithm, and after the database is upgraded to 12.2, and handshake is using the TLS 1.2 protocol. Because MD5 is a weak algorithm and it is not supported with the strong protocols. So if any certificates are signed with a weak hashing algorithm, we need to regenerate the certificates, means create a new wallet and create a new set of certificates and use it with the database and listener. Additionally, any new errors that will be logged when you're performing SSL handshake or client to SSL connections, they will be investigated and will be updated in the document specified, that is 2238096.1. I'm also presenting the list of document that can be used and for the SSL handshake configurations and troubleshooting. One is a step-by-step guide to configure the SSL authentication. You can use this document to create the SSL wallets and configure the database with these SSL wallets. Also, if it is a rack database, we have a separate document on how to configure SSL TLS on the Oracle rack. We have the troubleshooting guide along with the errors that will be reported during the SSL handshake. Also, after all the checklist, if the error still persists, we need to enable the database and client tracing. The SQLnet tracing will generate the SQLnet trace and they need to be reviewed upon to know the actual reason for the SSL handshake failures between the client and the server. Thanks for your time, guys. Over to you, Dirk.
Thank you, Srinivasa. So we're going to open the Q&A in just a moment. So please, use the chat panel to ask any questions. While we pause to collect your questions, I'd like to share some information on locating Advisor webcasts and how you can access the recordings from today's session. You can start from document 740-966.2, the Advisor webcast primary document. Select your product or also directly access the Oracle database doc listed on your screen and chat. And this is where you'll be able to see upcoming and prior webcast recordings. Please note that the design and user interface of the Advisor webcast index documents has slightly changed, although the tabs do remain the same. For today's webcast session and a list of all prior webcast recordings, go to the Prior Webcast Recordings tab and then click on the recording link. A PDF file with the webcast session slides can also be downloaded from here. If you have any follow-up questions on a webcast session, use the community link. The Q&A from today's webcast will be posted to this thread, as well as responses to the questions that we may not have gotten to throughout the webcast. And recording for this webcast will be available within 48 hours, which you can also access directly from the KM document listed on your screen. I've also posted this information on chat for your reference. I also want to mention that you can visit the Oracle Support Advisor webcast landing page, where you can find a listing of all upcoming Advisor webcasts across product lines, and you can register for any webcast that may interest you, or also provides a listing of all webcast replay links from the past month on the In Case You Missed It tab. I have posted the link to the landing page in chat for your reference. So next slide, we will go ahead and open it up for question. So if you haven't yet posted your question in the chat, please go ahead and use the chat panel. And please note that, again, these questions and responses will be posted in the community thread for your reference. So one of the first questions we had was, can we enable SSL between the user laptop and the database server?
Yes, I will take this question.
Okay.
Yeah, for connection to the database, there should need to be a client installed on the user laptop. If a client is installed on the user laptop and it can access the database from that client, then yes, you can have the SSL enabled for this connection also. If the database is enabled for SSL, The same way on the laptop, whatever the client you're using, it is either a SQL Plus client or any other JDBC client, you should get the certificates of the database and import it to the respective wallets or the keystore location of that client.
Okay. Next question. Can we use the default port 1521 as a TCPS port?
Yes, we can use the default port and convert it to TCPS, but we recommend to maintain the 1521 for the normal standard TCP communication and create an additional port for the TCPS. That is either it can be 1523 or 1525. You can have the communication over 1523, that is the TCPS port, but let the TCP port be available on the machine for any local connections or something which you don't want to happen over the SSL layer. They can still connect to the non-SSL port 1521.
Okay, thank you very much. So next question, can SSL be implemented in DataGuard as well?
Yes, in the DataGuard environment also, SSL can be implemented. The wallets, same wallet that is used on the primary, they can be copied over to the standby database. The connect descriptor where you will be using, the same connect descriptor should be updated both for the TCP as well as the TCPS protocols. The connect descriptor should be updated for both the primary and standby. It should contain the TCPS reference to both the primary and standby.
Okay, so this may be a similar question. Another user asked, if using DataGuard with TLS, is it still needed in the SQLnet.aura, as the database acts as a client?
Yes, SQLnet.aura, we need to mention the wallet location because here the SSL handshake will be two levels. One will be, the first connection will happen to the listener listening to the port, and the next to the database. So the SQLnet.aura on the DB home will contain the wallet location that will be used by the database. That is second handshake that will happen between the client and to the database. So SQLnet.aura is required to be updated with the wallet location.
Okay. Thank you. And what if the CA doesn't return a base 64 format certificate? Like, what other methods can be used to insert the certificate into the wallet?
Okay. For the wallets, the compatible format for the certificates to be imported is the base 64 format. If the CA, there are cases, CA will provide the certificates in different formats. Then we need to use any OS level tools to convert the certificates to base 64 format. Or else, if their conversion is not possible for whatever the restrictions, we need to ask the CA to issue the same certificates in the base 64 format. There are so many OS level utilities for conversion also available, from PFX format to base 64. Those things we can be used for locally also.
Okay, and is it possible to add a certificate already generated by a third party to the wallet as a requested certificate?
For a certificate to be added to the wallet, it needs to be in the base 64 format. So whatever format the CA gives you, you should convert it into the base 64 format. Then only it can be imported to the wallet.
Okay. And what's the easiest way to check the certificate validity?
In this PPT, we had shown that there's a VADA-PK certificate display command. When we done that command and the output I showed here, it shows the validity of the certificates. Along with the certificate details, it will show what is to what date and it's valid. So VADA-PK cert display command, it will give the details.
Okay. And I think there was just one more. User had a question regarding, they have hundreds of users connecting to database and they don't want to set up an Oracle wallet for all those users. They did try to use a note on connecting to the database with a client wallet. But is there any other options? They weren't able to get it to work. If you're not sure, that's fine. We can, post this to the forum when there's some more information. But do you have
Yeah. See the TCPS configuration here, we are establishing connection from any client to the database. For all the users to authenticate to the database, we can also use the same TCPS along with the user authentication, where the users will be at any the remote, like the users, any users that are connecting from the client to database, the database users, if they need to be authenticated over SSL, then the steps are some additional steps along with the what we do here, where we even create a wallet and assign the wallet to a user specifically. The CN will be created. So that is something which is not covered in this session, the user authentication with using SSL certificate. Here we are focused on the TCPS communication only between the clients and databases.
All right. And last question, what is the performance if you know degradation using TLS encryption? Is there any, if at all?
Yeah, the encryption decryption will have some impact, but I will take I'll keep this parked, or we can check it and I'll get back to details with more details once they post it in the community.
All right.
Yeah.
Fantastic. All right. So next slide, I just want to give a big thank you to you, Srinivasa, and for this very informative session. And of course, to our panelists, Naveen Bachu and Amita Balu, for answering the questions in the chat window. Any questions that we didn't answer in that chat, of course, will be collected and posted to the forum. We hope you found this webcast valuable today. And of course, we always want to thank you, each and every one of you, for taking time out of your busy days to join us. So thank you once again from all of us here at Oracle, and enjoy the rest of your day. And thank you. This concludes the webcast for today. Goodbye.